We are now at question 10 of the January 2025 CSEC Mathematics, paper 2. It says, alright, let's look at it over here. I copied it here already. The diagram. Right. The diagram below shows a quadrilateral OLMN. That's OLMN. And then to close it, you go back to O. In which O is the origin, alright? OL equal 4y. So OL is 4y, you can see it here. OM is 6z, so OM is 6z right here. ON is 2x, so from O to N is 2x, you can see the 2x here. The point A lies on LM, right here. The point A lies on LM, such that LA to AM is 1 to 2. So if you should measure it and say, suppose this was 10 centimeters, then this would be 20 centimeters, right? For example. So what they're saying is that this distance is 2 times this distance. So it's 1 to 2. And the point B on MN, they have B here, is such that MB to BN is 2 to 1. So from M to B is 2 times the distance from B to N. Okay. Alright. What do they say you should do now? Express in its simplest form Mn in terms of x and z. So let's copy this and put it over here. See what this is about. Express in its simplest form Mn in terms of x and z. So what you want here is Mn. Now you will use the triangle law or parallelogram law, equivalent, give you the same thing. Alright? So if you move from M to N, here what you will have is Mn being some resultant. You're going to add 2 vectors to get Mn as the resultant. Now, which 2 vectors? You could walk from M to N. But if there is some roadblock somewhere along the way, what would be the alternate route? Well, you could go from M to O, then from O to N. See that? So, you could go from M to O, then from O to N. You see that? So, this is a triangle where you're adding ON to O, MO to ON. Then the third vector, the third side closes the triangle, and that third side is the resultant. So you see, we'll put 2 arrows on the resultant. And notice, if you go around the triangle, the 2 angles that the 2 vectors you're adding, they follow each other. But if you should go back to M, it would be opposed. Your movement would be opposed by the resultant, right? So let's see how this goes. Mn. Mn is Mo plus On. You must show working, you know. Show how you get it. So Mn is equal to Mo plus ON. So that's from M to O plus O to N. But what is MO? MO is negative OM. So this is negative OM. Why I say that is because originally you have MO. You have OM with this angle, the original arrow, which is arrow being 6Z. So it's negative OM plus ON. ON is already following the original arrow that was given, so I don't bother to change it. So it's plus ON. Now let's see something here. What you're going to have? OM is 6Z. So MO is what? Is negative 6Z. OM is 6Z. So negative OM is negative 6Z. Like to cross my Z so that it doesn't look like 2. Plus ON. And what is ON? Going from N to O is 2x. So it is 2x. Alright? So it's in terms of x and z. You could write it with the x first, 2x minus 6z. And you could also factorize and get 2 outside the bracket, x minus 3z inside the bracket. So there you have mn in terms of x and z. So let me just write it here. Mn is equal to 2x minus 6z, because mn in terms of x and z mean you have x and you have z and you have numbers. Alright, so that's part one. Let me see, 1 mark for that. See what else they say. Find in terms of x and y in simplest form the expression for ln. That's part 2A. Let's copy and paste it over here and see what's going on. You already have the working here. I don't want to stray too far from the diagram, so I'm going to erase the work, leave the answer up there because I might use it, and then pull this down here. Now let's just erase the markings on the diagram and use a fresh diagram. In terms of x and y, in its simplest form, the expression ln from L to N. Alright. And by the way, remember, even if I don't remember to remind you, you must try all the questions on your own before you watch me work them out, right? And remember, any mistakes or any mistakes you identify and might make, or any question you have, any comments, put them in the comment section, right? Alright, and also, if you're not a subscriber, make sure you subscribe and share the video with somebody else, alright? So that those are part of your homework. So, what they ask for is ln. What is ln? Alright. If you go along ln, one alternate route you could take is to go L to M and M to N. But you don't have any writing here in terms of x and z or x and y. Let me see, they have x and y. So, in terms of x and y in its simplest form, what you could do, if you're not able to go straight from L to N, you could go L to O, then O to N, and you end up the same place, right? So, in terms of this, you could go from L to O. So you could go along this arrow, then O to N. So you go along this arrow, alright? So as you see, Ln is LO plus ON. Let's write that down. Ln is equal to LO plus ON. Alright? Now, you want it in terms of x and y. That means you should end up with x's and y's and numbers. Alright? Now, LO. You notice that originally the arrow that was given, it ran from O to L. But now you're going in the opposite direction from L to O. So if you say OL is 4y, right? We say OL is equal to 4y. So then what happened? LO is equal to negative 4y. Inverse vector, right? Because O to L to O is the negative of going O to L. OL was 4y, so LO is negative 4y. What is ON? ON is 2x. You see it here. So ON is equal to 2x. So therefore, Ln is equal to LO, which is negative 4y, plus ON, which is 2x. Okay. Well, that looks like it. And you can factor it out as, well, you could write 2x minus 4y and factor out 2 and get 2x minus 2y. So, let's write it here. That Ln is equal to 2x minus 4y, which is 2x minus 2y. This up here that we had earlier would have been 2x minus 3y, 3z, if you factor out 2. Okay, so you have two answers so far, right? Ln. So remember, Ln is going from L to N. You could go from L to O, then O to N, and end up the same place. So therefore, Ln is LO plus ON. You see that? LO is negative 4y. ON is 2x, so it's negative 4y plus 2x is the same as 2x minus 4y. Okay, so there you have that. Let's erase the work that we have to make space, and then we continue. Let's see what's going to happen next. Okay. Show that AB equals 2/3 2x minus 4y. That will be interesting. Space and continue here. Let's pull this down. Put it down here. Alright. We're going to show that AB from A to B. Okay. Let's erase what we did before. And we're going from A to B. AB. Alright. Now, here. Oh, and by the way, how many marks did they give for these parts again? 1 mark for up here, but 2 marks for this. Only 2. 2 marks. So we're going from A to B. Alright. Now, if you're going from A to B, you end up the same place as when you go from A to M and then M to B. So AB is AM plus MB. You see that? Going from A to B, places you at the same point as going from A to M, then M to B. So AB equal AM plus MB. So AB equals AM plus MB. AB is AM plus MB. All right. Now, looking at this, my strategy here is this. I can go from L to M. They are not, LM is not marked, but going from L to M is the same as going from L to O, then O to M, which is marked. All right? Now, LM, and you have AB, AM, LM, this was LN. All right. If you go from L to M, you could say that LM is equal to LO plus OM. All right? I think I'd worked that out before, but erased it. Well, let's look at it again. LM is LO plus OM. So LM is LO plus OM. All right, LO plus OM. But LO is negative 4y and OM is 6z. So it's negative 4y plus 6z equal negative 4y plus 6z. All right? That's LM. LM is in the same direction as AM. But notice, AM, if you cut them, 1, 2 parts, A to M, you'd have to jump 1, 2 places. L to M is 1, 2, 3 places. So AM is 2/3 LM. You see that? So from A to M is 2/3 L to M. So AM is 2/3 LM. You see that? L to M is 2/3. A to M is 2/3 L to M. All right. Now, what that means, AM is 2/3 negative 4y plus 6z. All right. So AM is now is going to be, all right, let's keep it as this. Let's not change it just yet. You have AM. So you can write here that AM is 2/3. Let's put it, all right, let's keep it as this. Negative 4y plus 6z. Now, remember, this is AB equal AM, which we found a while ago, plus MB. We need MB now. All right? Going from M to B. MB is 2/3 MN. You see that? If this was 20, this would be 10. So everything would be 30, right? 20 out of 30 is 2/3. See that? So MB is 2/3 MN. MB is 2/3 MN. Alright? Now MN is this. We looked at it already. You go negative 6 plus 2, negative 6z plus 2x, or 2x minus 6z. We saw it here. Alright? So Mn is 2x minus 6z. So this is 2/3 2x minus 6z. 2x minus 6z. Make sure you see that part. 2/3 Mn, which is 2x minus 6z. Alright? Now, we have our AM here, and we have our MB here. Let's put it together. They said to show that AB is this. So, AB now is equal to AM, which is 2/3 negative 4y plus 6z, which we have up here, plus MB, which is this. MB is 2/3 2x minus 6z. Alright? That's AB. We want to simplify it now. This is equal to, we could factor out 2/3 outside the bracket, and inside the bracket you have negative 4y plus 6z plus 2x minus 6z. When we remove these round brackets, we don't need them anymore because we had factored out the 2/3. Alright? If you want to multiply inside the bracket and then factor out, you could do that, but that would be more work. No, this is 2/3. What do you have inside the bracket? Put the x together, or the x here, minus 4y plus 6z minus 6z. See that? Now this is equal to 2/3. What happened here now? 2x minus 4y. Well, guess what? 6z minus 6z is 0, so the z is gone. There is 2/3 2x minus 4y. You have 2/3 2x minus 4y. You see that? So that is shown. Okay. Now, it says here, based on your results in part 2, state 2 geometric properties relating ln to AB. Alright, so let's copy and paste that over here. Where is it? Okay. So, based on your result in part 2, say 2 geometric properties of relating ln to AB, ln and AB. ln from L to, oh my. Okay, L to N. This is ln. Right? That's ln there. Alright, now the fact is, you have AB here, is this, and then ln is 2, x minus 2 is 2x minus 4y. So let's write it back. Ln is 2x minus 4y. Ln is 2x minus 4y, while AB is 2/3 2x minus 4y. Alright, and they ask for you to compare the two of them. Alright, so you have AB and ln. Now, here, you can see that they're parallel, right? They run in the same direction. So you could say they have the same gradient, alright? But in terms of length now, you could say AB is 1/3 the length of ln. AB, oh wait, hold on there, AB and ln. If you divide them and say ln over AB, how much longer would ln be? It's 2x minus 4y divided by 2/3 x minus 4y. Alright, so let's do this first. 2x minus 4y, these would cancel. So this would be 1 over 2/3, which is the same as 3 over 2. Right. So ln over AB. You can see that ln is the longer one. How much longer? You could say it's 3/2 or 1.5 time. So ln is 1.5 times longer than AB, right? And of course, ln is and AB are parallel. They're parallel, right? You could also say they have the same gradient. Since they're parallel, they would have the same gradient, of course, right? So you state the two geometric properties relating LM and AB, 2 marks. What else is there? Okay, part B is about matrices. So let's do part B in our next video.